Bringing you example 3, everyone, we have a $5,000 and $5,000 is invested at 12% compounded monthly. The future value of the investment at any time t in years is given by that. And so we want to graph this function in GeoGebra. I'm going to go ahead and just turn that off and turn that off so that I have a blank screen here. I will go ahead and copy this over to GeoGebra. Again, the other way to do it, everyone, is just to open a new GeoGebra window and then use the Shift key to scroll out on your, and nothing showed up. What's up with that? It's not liking me today. It looks like I am going to have to go file new. I will say don't save. Let's see if it takes my input this time. There we go. So Shift, pull down until I find a line. It's going to take me a while. And then we will pull over until we kind of get a picture of what seems like it's going to be what we want. So our question is, how long will it take for the value of this investment to double, which is to reach $10,000? And so I can estimate it here on GeoGebra. It looks like that will take about 6 years. How long will it take for the value of the investment to reach $50,000? And we'll find these answers exactly in Wolfram in a moment. But for now, we're just going to sort of estimate. It looks like about 19 years to reach 50,000 bucks. How about 100,000? So remember, 19 doubled. If it took double the amount of time to double the amount of money, to go from 50,000 to 100,000 would take 19 years, plus 19 years would take 38 years. Let's see how long it takes using this to double our money. 25 years is when we reach $100,000. So we gain another $50,000 in just 5 years. So again, you'll notice here, this obviously didn't grow $50,000 in 5 years, but it did over here. That's pretty wild. So these are, again, time is fertilizer for money. You have to be patient, put the money in, let it sit there for a very long time, and just watch it grow like crazy. So examine the amount of time it took to reach 50,000 as compared to the time it took to reach 100,000. Let's look again at what's happening here really quickly. We can see plain as day, everyone, that if I pull this out so I can still see 50 and I can also see 100, let's see if it will do it for me. There we go. So to get to 50,000 took nearly 20 years. To go from 50,000 to 100,000 only took 5 years. So to get our first 50,000 took 20 years. To get our next 50,000 took 5 years. And again, it's because these exponential functions get increasingly steep as time goes on. Once more, this is why the rich stay rich. And so if you're looking at this, everyone, you could say realistically, if you wanted to leave your child or yourself a $100,000 gift, one way to do that would be to find an investment that yields 12% and put $5,000 away today. In 25 years, you should have about $100,000 sitting there. So we're going to go ahead and do the math for this, everyone. I'm going to switch over to GeoGebra. Again, this is just sort of a visual of what's going on with it. Probably the easiest way to handle this, as we have before, is to just copy this out of the presentation, put it into Wolfram, and let it fly. So copy, paste. And we need, for the first bit here, we need, what do we need? We are looking for how long will it take for the value of this investment to double. So we want our S, our final value, to be $10,000. We're solving, Wolfram is going to solve this for us for t, and it will tell us how many years it takes for it to double. We've got the answer t equals 5.8. We'll just stop at 5.8. I'm going to pause the video for a moment and write some math down, then we'll talk about it when I come back. So we can see, everyone, I just sort of wrote down what I put in Wolfram and what Wolfram gave us back. So it will take 5.8 years to double our money. For doing nothing. We just left the money there and let it go. So that's going to be part B. Again, I'm not going to be asking you to turn in any graphs or anything like that in the homework. This is just strictly for me to be able to sort of show you what's happening with this. How long will it take for the investment to reach 50,000 and 100,000 respectively? So we're going to pull the iPad out of the way here a bit. We want to know how long will it take for it to reach 50,000. 19.3 years. So it will take 19.3 years for the value of the investment to reach 50,000. And as we saw in the graph in GeoGebra, I estimated it to be about 20 years. We were pretty darn close. Now we want to know how long it's going to take for this value to double again and go from 50,000 to 100,000. Remember, it took us nearly 20 years to get to 50,000. Now we're going to jump it up to 100,000. So in 25 years, 25.1 years, if I was to round to the nearest tenth, it will take 25.1 years to reach a value of $100,000. So we do have something to talk about here, everyone. We need to notice, and this is for part D, that it took 19 years to reach $50,000 and 25 years to reach $100,000. That's not 25 more years. That's 25 total years. So in just 6 short years, we gained another $50,000 in this investment, which is crazy. So the money for part E, the money grows faster as the investment ages. Super important for us to understand. How long will it take for the value of the investment to reach $150,000? How about $1 million? And so we're just going to run those in here and see what we get. Remember, everyone, we started with $5,000. And so this $5,000 will turn into $150,000 in 28 years, 28.5. So for F, 150,000. What did I say? 28.5 years, I believe. Which is pretty wild because we just went from 25 to 28. So in 3 years now, we got another $50,000. So our spread here, everyone, between C from 19 to 25 was about 6 years to get 50,000 more. From 25 to 28 was only 3 years to get 50,000 again. And so you can see that it's taking half the amount of time now to get $50,000 because the investment is growing faster as time goes on. Then 1 million, everyone. Let's see, 1 million seems to be a big time number for people. Let's see how long it would take for this $5,000, given these circumstances, to turn into $1 million. It looks like we would have $1 million in 44.4 years. You may be thinking to yourself, this is impossible. This can't be the way that it works. Yes, it is. And this is exactly why there are people in the United States that have ridiculous amounts of money because their family was able to play the game and make the money work for them. So again, everyone, I'm 43 years old. If my parents had put $5,000 away from me when I was a newborn under these conditions, today, well, 1 year from now, I would have $1 million sitting waiting for me. Pretty cool thing to think about and maybe use to plan some things in the future.